In this video, let us solve some problems on the concepts that we have learned so far. So they are given two vectors u, v, and they are saying they are orthogonal, and the length of the vector is given. Then what are the values of a and b? What is that? First, they are given this length of vector is equal to 3. So this means square root of 2 square plus a square plus b square is equal to 3. So a square plus b square is plus 4 is equal to 9. A square plus b square is equal to 5. Then they are orthogonal, means what? U into v transpose is equal to 0. Now, what is u? 1, 2, 2. V is transpose equal to 0. So this is nothing but 2 plus 2a plus 2b is equal to 0. So a plus b equal to minus 1, or I can write b is equal to minus of a plus 1. So substitute this b here. It is a square plus minus a plus 1 whole square is equal to 5. So a square plus 2a plus 1 minus 5 is equal to 0. 2a square plus 2a minus 4 is equal to 0. That is a square plus a minus 2 is equal to 0. So we factorize this. A square plus 2a minus 2 is equal to 0. Then a plus 2 minus 1 a plus 2. This is a equal to 1 or minus 2. Okay. Then if a is equal to 1, what is b? So b is equal to minus 2. So then if a is equal to minus 2, then b is equal to minus of minus 2 plus 1. That is 1. Minus 2, 1. Minus 2 plus 1. So 1 comma minus 2, this is the correct. Two non-zero vectors u comma v belongs to Rn, satisfy u plus v equal to u minus v. Length of u plus v equal to length of u minus v. Then what about the relation? So to solve this problem, so to find that, you should check the angle between them is 90 or 0 degree, or both are equal. So you have to get the cross product or dot product from this. Let us take the square of this. U plus v square is equal to u minus v square. So this is nothing but I can write it as u square plus 2 into u dot product plus v square equal to u square minus 2uv plus v square. So this, if I take that, this gets cancelled. So for uv is equal to 0 dot product. So u dot v is equal to 0 means what? So they are perpendicular to each other, that is orthogonal. So they are not parallel. uv, the lengths are equal, they are saying. They need not be equal. The length may be or may not be equal. This is also not true. Both A and C not true. So A is the answer. If u and v are orthogonal and u, length of u equal to 2, v equal to 3, then find u plus v. Okay. So how will you find this? Again, so if you take the square of this, how will you find the dot product? U dot V is equal to U into V cos theta. Already we know. So this is 2 into 3 into cos of theta is 90 degree because they are orthogonal. So this becomes 0. Now U plus V square is equal to, again, U square plus V square minus 2 U into V, sorry, plus 2 into U V. So that we already got as 0. So this is 2 square plus 3 square. This is 2 plus V whole square. This is 4 plus 9. So U plus V is equal to square root of this, that is square root of 13. This is the answer. Which of the following pairs of subspaces in R cube are orthogonal complements? Okay. So they should belong to the same span. That is the meaning. Orthogonal complement means what? So if U is the span or my subspace, then U complement. This is the represented as the orthogonal complement of U. So how will you find? That means what? The vector given here and here both should be orthogonal to each other. That is, the dot product should be 0. That is the meaning. So let us take the option A. Span of 1, 1, 1, 1, 1, 1. And they are saying here x plus y plus z equal to 0. This means what? This is U, say vector. This is B. B, x plus y plus z means what? X plus y plus z means, so all are same, 0. Or you can say let us write only x, y, z. So now you take the dot product of this. This becomes x plus y plus z. What is x plus y plus z? It is 0 only. So this is the complement, orthogonal complement. Next, B. U is 1, 0, 0. And then there are, it spans 2 vectors here. So check with each, because each vector should be complement, orthogonal complements. It is 0, 1, 0. So they have unit lengths, and then so dot product is 0. Similarly, one more is there. So 1, 0, 0 with 0, 0, 1. So dot product is again 0. So this is also, both are orthogonal complements. Then C, x, y, z, x minus y equal to 0, x, y, z, x plus y is equal to 0. So I will write, so x, let us write x, then x minus y equal to 0 means y is equal to x. So this means this is also x, and let us say z is not given, let us say it is a 0. This should be x minus x, because y equal to minus x here, and then 0. So to take this, let us say 1, 1, 0. Okay. Then 1 minus 1, 0. Let x equal to 1. How will it find now? It is not 1 into 1 is 1. So it is not 0. The dot product is not 0. So this is not orthogonal complements. Next, D. Span of 1, 1, 0 U is, then here it is 1 minus 1, 1. So again 1 into 1 is not 0. So this is also not orthogonal complement. So A and B are the answers. Find the dimension of orthogonal complement of U. If U is a dimensional subspace of R5, that means what? Dimension of U plus dimension of orthogonal complement should be equal to n. So n is 5 here. This is the entire space. These are the subspaces of that. So they given this as 2. So this will be equal to 5, means this will be equal to 3. If Q is an orthogonal matrix, which of the following statements is true? Okay. Columns of Q are linearly independent. Yes. No. If Q is an orthogonal matrix, which of the following statement is true? Columns of Q are linearly dependent. No. I thought of independent. If they are independent, then it's correct. So they are not linearly dependent. See, all orthogonal columns are linearly independent because their dot product is 0. Q transform equal to Q is equal to I, but this is not equal to I. See, this is the definition. Both should be equal to I. Q transpose into Q equal to Q into Q transpose should be equal to I. That is the definition of orthogonality. So this is also not true. Each column of Q has unit length. For orthogonal matrix, this is true. Determinant of Q can be any real number. No, it can be only plus or minus 1. Next, let Q equal to this matrix. Which of the following are true? Q is orthogonal. Check the orthogonality. So length of this column is 1. This also 1. The square root of 1 means 1 only. So, and then this dot product is 0. So it is orthogonal. Q represents a rotation by 90 degree. So how will you find? I told you this matrix cos theta minus sin theta, then cos theta sin theta gives the rotation matrix. So if it is by 90 degree, you put cos 90 minus sin 90 cos 90 plus sin 90. So this will give me that matrix. So cos 90 is 0 minus 1 0, but this is sin theta cos theta. So sin 90 cos 90. So this is 1 0. So this is the matrix. So it represents rotation by 90 degree. Q is symmetric. No, 1 minus 1. It is anti-symmetric. Q symmetric. Sorry. So this is not symmetric. Qt equal to minus Q. So if you transform this, what is Q transform? I will get Q transform is equal to 0 1 minus 1 0. So this is nothing but if I take minus Q, this is 0 1 minus 1 0. So both are equal. This is also true. Next, for an orthogonal matrix Q, the length of Q into X in a matrix or vector X is always equal to X. This is true. This implies what? Preserves the distance but not angles. Preserves both distance and angle. This is the correct answer. Changes both distance and angles? No. Only scales the vector? No. Only preserves distance and angles. I told you the volume is same. Let Q equal to this. Compute the determinant of this. Very straightforward question. Cos square theta, determinant of is minus into minus sin theta into sin theta. So this is cos square theta plus sin square theta equal to 1. Answer is 1. If P is the projection matrix, which of the following must hold? This should hold. So, no, P square into P. If they say P square equal to I, so it is an identity matrix. Is it a condition required? No. P square should be equal to P. That is projection means P square equal to P, idempotent matrix. This need not be true unless they mention anything about I here. Not mentioned anything. So P transpose equal to P inverse. No. Then this becomes orthogonal, not projection. Determinant of P is equal to, if it can be 0 or 1, not only 1. So only B is correct answer. Which of the following matrices represent orthogonal projections in R square? What are orthogonal projection? For orthogonal projection, P square should be equal to P. That is the first condition. Second, P transpose should be equal to P. So first you check this. P transpose equal to P means it's a symmetric matrix. So first check which are symmetric here. This is symmetric. This is symmetric. This is also symmetric. 0 1, this is not symmetric. So you ignore this. Now we check for which the p square is equal to p. Okay, so how will you check p square equal to p? You multiply this matrix twice. 1 0 0 1 0 0 0. This will be 1 0 0 0. I'm getting back the same matrix, so this is true. Okay. Then what about this? So this is 1 1 1 1 1 by 2 into 1 by 2 1 1 1 1. This will be 1 by 4 into 1 into 1, so 2 2 2 2. So this is, I can write it as 1 by 2 1 1 1 1. So this is also correct. This is not true anymore. So see, one more time you try. 0 1 1 0, this into 0 1 1 0. So if I multiply, I should get the same matrix. So 0 becomes 1. So this is a failure here. See, I could get 0 here. So this is not true. Only A and B. Find the projection of U V equal to 2 3 onto U equal to 1 1. So what is the span here? This is the span. That is the meaning. So how will you find the projection? Projection of, say, V here on U. That is what they are saying. So U is a subspace, or you can say W is a subspace and U belongs to this W. So this is given as V into V transform into V inverse divided by, so into V transform. Okay. So this is my projection matrix, and then I have to find multiply it to U. Okay. So sorry, this should be V and this is U. First, for projecting onto U. So this is U. This is projection of V on U. Okay. There's a mistake here. Now, this is nothing but U into U transpose divided by U transpose into U. So, and into your projection V. So, find out this value. So, U is 1 1 into transpose of this is rho divided by 1 1 into so into this V. So this is 1 1 1 1 divided by 1 plus 1 is 2 into V. So this is 1 by 2 1 1 1 1 into what is V? V is 2 3. So that will become, I'm writing it here. So this will be 1 by 2 into 2 plus 3, also 2 plus 3. So the projection of V on U that belongs to subspace equal to 1 by 2 5 5 is the answer. Let A be a symmetric matrix. Then for any x comma y, x transpose AY equal to y transpose AX implies. Okay, so let us check this. X transpose AY is equal to y transpose AX. This is what they are given. So let us check the transpose first, whether it's symmetric or not. Y transpose to AX, transpose of this. So what is symmetric? A equal to A transpose, right? So here this is the entire, say, X, that is not X. Take some P. So that means P equal to P transpose I am finding. So this will be, I can write it as X transpose A transpose Y transpose of transpose. Okay, so this is nothing but X transpose. A transpose is A, Y transpose of transpose is Y. So this gives the same result. That means this is symmetric. Which of the following matrices are both orthogonal and symmetric? So first check symmetry. So 0, 0 symmetric, 0, 0 symmetric, 1, 1 symmetric, 1 minus 1, this is not symmetric. Then how will you check orthogonal? Length of their vector should be 1 and dot product is 0. So length of the vector is 1, 1 here. And the dot product is 0. So this is orthogonal and symmetric. Here also 1, 1 and then 0 is the dot product. This is also true. Here also 1, 1 and what is the dot product? 0. So this is also the orthogonal and symmetric. For a projection matrix P, compute the rank of I minus P in terms of rank of P and N. What this means? I minus P, if P belongs to W space, that is subspace W projection, that means what? I am projecting this on my plane. The explanation I gave you. This is plane. Let us say this is W. These are the vectors, column space of W. Okay. So P projects your vector say U on this. Now this is W. There are orthogonal vectors in the column space. They are orthogonal to these vectors. This is represented as orthogonal complement. So if I project I minus P, it will be projected on this orthogonal complement of subspace W. So that means what? Rank of P plus rank of I minus P is equal to number of column space, that is dimension of column space. So this means what? Because they are perpendicular. This implies W, this implies complement of orthogonal complement of W, the subspace. This is N minus rank of P. Okay. If A is orthogonal and symmetric, then which of the following is true? The orthogonal and symmetric. A into A transpose equal to A transpose into A is equal to, and then you have A is equal to A transpose. So that means what? T. This is equal to I. Now, if I put A transpose as A, so it should be A square, that is equal to I. This is true. A square need not be 0. Determinant of A is not equal to 0 because it's a orthogonal matrix and symmetric. Okay. These are not correct. Let Q be an orthogonal matrix. Then which of the following are true? This is always true. The length is preserved. Then eigenvalues of Q have unit magnitude, that is plus or minus 1. No, magnitude is 1. Q inverse equal to QT. Yes. Because Q transform into Q is equal to I. So Q inverse is equal to Q transpose. Q must be symmetric, need not be. Find a unit vector orthogonal to both U and V. So to find new vector W, which is orthogonal to U and orthogonal to V. So W into U should be equal to 0. Let us say this is X, Y, Z. Okay. And U is 1, 1, 0. Is X plus Y equal to 0. That is X equal to minus Y. Here W into V is equal to 0. So X, Y, Z 1, 0, 1. V equal to 0 is X plus Z equal to 0. X equal to minus Z. Okay. So that means what? Or you can write z equal to minus x. So this w is equal to x, or let us say y equal to minus x. So x is 1 in both, so 1. So y is minus x and z is minus x. So 1 minus 1 minus 1. Okay. Now this is the vector. So if you multiply, check it. 1 into 1 minus 1 into 1, 0. So it will be 0. Dot product of WV is 1, 0, minus 1, 0. So this is the vector. What they are asking? Unit vector. Unit vector means the length should be 1. Okay. So if I multiply for W, if I calculate the length, it should be 1. But here it is root 3. So divided by root 3. That is W equal to 1 by root 3. 1 minus 1 minus 1. This is the answer. If u and v are orthogonal non-zero vectors, then the projection of u on v is, okay. So there are two orthogonal vectors u and v. Then the projection of u on v. So projection of u on v belongs to some column space w of w. So this is how will you find the column space? So that is nothing but v into v transpose into v inverse into v transpose. Okay, this is the projection matrix into the u, the vector I want to project. You see here, you can just rearrange it, v into u into v transpose v inverse into vt. What is this? This dot product is 0 because they are orthogonal non-zero vectors. So orthogonal means 0. That means what? The projection is 0 means it's a 0 matrix. Is the answer. Let P equal to this be a projection matrix. Then which of the following is true? If P is projection matrix, you already know it is this. And also check if it is symmetric also. How will you check the symmetric of this? So A transpose of A inverse AT. Okay, first convert this. A into A inverse into A transpose inverse of this. Then into A transpose. Take the whole transpose of this. If I take the whole transpose, it becomes A into, so this is A transpose into A inverse into A transpose. Okay. So this is equivalent to this, hence this is also correct. Columns of A form the orthogonal basis of column space of P. What it means? Columns of A form an orthogonal basis of column space of P. So this is what they are saying. They are not, they don't form an orthonormal basis. See, they are saying, see, this column space is for W, and they are saying this complement of orthonormal means complement of this. So it is not true. The columns of A form basis for columns of P, not for the orthonormal basis for this. P projects onto row of A. No, P projects onto column space of A. Okay, only A and B. if V is decomposed as V parallel plus V orthogonal, okay? Parallel means angle between them is 0. You can imagine like that. Orthogonal means angle between them is 90 degree. Related to a subspace U, then what are the conditions? V parallel lies in U and V perpendicular lies in orthogonal complement, that is C. We draw the space, or this way I told this is W and this is orthogonal complement of this. Okay, so whatever vectors I drew here in my explanation, see, all are parallel. Okay, W contains all parallel. Orthogonal of these are all perpendicular to this. So that means what? This all parallel lies in U. So here they are given it as U, and perpendicular lies in there. Right? This is true. So this cannot be true. That is the meaning. Let U1 and U2 are these two vectors, compute the angle between them. So the angle is given as cos theta is equal to U V length of these vectors, and then you have U1 dot U2. So this is U2 and U1. What is this? 4. It is 1 into 2 plus 2 into 1 divided by length of this is 1 square plus 2 square, 4 root 5. Root 5 into root 5. So this is 4 by 5. So theta is equal to cos inverse 4 by 5. We'll get it around say 37 degrees, something like that. Okay. Next. Which of the following are true for orthogonal subspaces U and V? So U and V are both orthogonal subspaces. U intersection V is equal to null. So what it means? Since they are orthogonal, there is no intersection. So this is true. Dimension of U plus dimension of V is less than or equal to n. That is true. So what they are saying, this is my space. So this is U, and here I will get this part and this part. The projection, if it is here, this is U, column space of U. This is orthogonal to the column space of U. That is orthogonal complement. That means dimension of both should be some less than or equal to n. So complement of this, so U complement of this orthogonal is U only. This is true. Projection of U on projection of V of X. Okay, projection of V of X on V. Okay, V is what? This here. Then projection of this on this is 90 degree. No, so that means what? That is 0 only. I cannot get a projection here. So it is the same. This is also true. So thank you for watching. Please like, subscribe and share. In the next video, we will continue some more advanced concepts in this vectors and linear algebra.